Hello everyone, today we are going to see two major sorting algorithms that are merge sort and quick sort. So, a question may arise that what is common between merge sort and quick sort? So, the answer is that they both are divide and conquer algorithms, or a question might come that what are the two sorting algorithms that are based upon the concept of divide and conquer? So, the answer is merge sort and quick sort. Now, starting with the merge sort. So, what the algorithm says is the merge sort function repeatedly divides the array into two halves until we reach a state where we have to perform merge sort on a subarray of size 1, that is p equal to r. After that, the merge function comes into play and combines the sorted arrays into larger arrays until the whole array is merged. So, what we do here is we divide the array into two parts. Then again repeatedly the two divided halves are again divided into 2 until the subarray is of size 1. So why we are creating a subarray of size 1 is because a subarray of size 1 is already sorted. So after dividing the whole array into subarrays of size 1, what we do is we merge all the subarrays using the merge function, and finally we get the whole array that is sorted. So this is the source code. Here we are given an array and last and the left and rightmost part. So this is performed until left is less than r. So we find the middle element and then we perform the same algorithm first on the leftmost part and then on the rightmost portion. And then after dividing and after performing it, what we do is we merge the sorted subarrays using the merge function. Now we will look into how the merge function work. So what we first do is we create two first we create two arrays, that is L and M, and these are the size of what we are creating with the array. So then we are putting the values in the L array and in the N array, and using these variables we will maintain the index of subarrays and the main array. So now this function is basically used to merge the two arrays. So what we will do here is while ni is less than n1 and j is less than n2, that is both the subarrays are present. So we will first check their elements, that the element of first array are in L and second are in M. So we are checking which element is less than or equal to, and then we are putting, if L1 is less than or equal to, we are putting array k I value in array and then incrementing I plus plus, else we are putting the M value in array and incrementing the j plus plus. Also we will incrementing the k index. It is used for the indexing of the main array. Now if one array is finished, what we will do it, if I is only less than n1, then we will only put the elements of L and increment the I and k, and only if the j elements are and only if the elements are left of the M array, what we are going to do is we are only going to put the elements of M in the array and incrementing the j and k plus plus. So this was a simple source code of merge sort. This was the algorithm, and these both are the source code. Coming to time complexity, in the merge sort is efficient compared to the bubble sort, insertion sort and selection sort because of the time complexity, since it is less, which is n into log n, and this, but here the space complexity is more, that is n, because of the array we have created here of n size. Now coming to the quick sort. So as we have seen, quick sort is also based on the divide and conquer algorithm that picks an element as a pivot and partition the given array around the picked pivot by placing the pivot in its correct position in the sorted array. तो इसमें हम क्या करते हैं, रिपीटेडली एक पिवट चूज करते हैं और उस पिवट को अपने एरे में एक उसकी करेक्ट पोजीशन पे पहुंचा देते हैं. तो क्या होता है, उसके लेफ्ट मोस्ट पोर्शन में उससे छोटे एलिमेंट्स होते हैं अनसॉर्टेड और उसके राइट मोस्ट एलिमेंट में उससे बड़े एलिमेंट्स होते हैं अनसॉर्टेड, और हम इन दोनों पोर्शंस पे फिर क्विक सॉर्ट लगा देते हैं. सो दैट इज द होल एल्गोरिथम. तो हम एक डिवाइड एंड कंकर परफॉर्म कर रहे हैं अराउंड द पिवट. सो व्हाट इज द सोर्स कोड? तो हम ये लूप चलाएंगे जब तक low is less than high and we are selecting the pivot element in pi. Then we are performing the same quicksort function in the leftmost portion and then the rightmost portion of pivot. Now coming to how to select the pivot element. So this is the whole algorithm of selecting the pivot element. You can select any pivot element you want. Maybe it can be the leftmost element, rightmost element, middle element, or any random element. So here what we are doing is we are selecting the rightmost element as the pivot, and then we are creating a pointer for the create element, and then we are traversing each element of array and comparing it with the pivot. So this is done to place it in the correct position. So if array j is less than pivot, then we are incrementing the I++ and swapping them. So by doing this algorithm, at last we are returning the position of the pivot element. Now coming to the time complexity, its best case is n log n, but in the worst case it goes up to n square. But its average case is said to be n log n because 50 to 75% of times it is basically in the range of n log n only. So that's why its average case is n log n. When the space complexity is less compared to the merge sort, you can compare it with that also, that it is only log n. So this was all about both the algorithm, merge sort and quicksort. So here you can have a review of both the algorithms. This was the merge sort. Okay, so thank you. In the next video we are going to see about the heap sort and compare all the sorting algorithms. Thank you.